Alright, this video is about the rational zeros theorem, and before I tell you what the theorem is, let me tell you what we're going to be using it for. So, we are going to be using this to answer the question, what are the possible zeros of a polynomial? So let's say that you're given some really long, complicated polynomial, and you're asked to find the zeros. Well, finding the zeros is a really important thing, right? Because the zeros can tell you where the graph crosses the y-axis. You can use the zeros to find the critical points, the min and the max and so forth. So the zeros are really important, and we're going to use them to do a lot of things. We have to be able to find them. Now, how do you find the zeros from this function? Well, you have to take it and you have to factor it down into pieces. And before this, we have learned a lot of different ways about how to factor polynomials. We did factor by grouping. We've done just unfoiling. Most recently, we've been talking about synthetic division and about long division. And all of those are going to break the long polynomial down into its individual factors. So after you've taken your polynomial and you've broken it down into factors, then in order to find the zeros, you take each one of those factors and you set each factor equal to 0. So I say x plus 3 equals 0. What does x equal? X equals -3. And you take each factor and you set it equal to 0 and you solve for x, and you're going to find all the zeros. Well, this rational zero theorem is going to tell you what all of the possible zeros are before you've actually factored it out, before you've actually done that part. So, what are the options? Now, when you factor it and you look at the zeros, sometimes you get numbers that are whole numbers or fractions. Those are rational numbers. But however, the zeros could also be irrational numbers, or you could also get complex or imaginary numbers for your zeros. Well, this rational zero theorem is going to tell you what the zeros could possibly be before you have even done the factoring part yet. So before you've even worked it all out, you can just tell what the zeros are going to be using this theorem. Now, this theorem is not going to give you all possible zeros. It's only going to give you the zeros that are rational, not the irrational ones and not the complex ones. All right, so let's see if we can use this theorem to tell what our zeros are. Okay, so the rational zeros theorem says that all the possible rational zeros are a fraction of the factors of the last constant term over the factors of the leading coefficient. Okay, so looking at the large polynomial, what you're going to do is you're going to find the factors of that last number. And you're going to find the factors of the first coefficient, and you divide them. And when you divide them, those are going to be all of the possible zeros. So you're going to find the factors of the last number. In this case, what factors? I need to find numbers that go evenly into it. So the factors are the numbers that divide evenly. Okay, so we want to find factors, and the factors are the numbers that divide evenly into the number. So what numbers go into 2? Well, the factors are 1 and 2. So what numbers divide evenly into 15? 1 goes evenly in, 2 is not going to be a factor, 3 goes evenly, 5, and also 15. So all of the combinations of this number on top and this number on bottom, dividing these two, gives us all of the possible rational zeros. Okay, so let's actually go ahead and do that example. Let's list all the possible zeros of this polynomial. So the zeros are going to be the factors of 2 divided by the factors of 15. Okay, so the factors of 2 were 1 and 2, and the factors of 15 were 1, 3, 5, and 15. Now I have to list out all of the possible options that have one of these numbers on top and one of these numbers on bottom. So let's list them out. I can have 1 over 1, 1 over 3, 1 over 5, 1 over 15, or I could have 2 over each of the numbers. Okay, or I could have 2 over 1, 2 over 3, 2 over 5, or 2 over 15. Okay, so now I'm going to simplify each of those down for my answer. So, and each of these numbers could be both positive or negative. So my options are either 1 divided by 1 gives me 1. So the possible zeros could be positive or negative 1. 1 over 3 would be 1/3. I could have positive or negative 1/3. Positive or negative 1/5. Or I could have positive or negative 2 over 1 is just 2. 2/3, 2/5, or 2/15. Okay, and those are all the possible zeros. Let's try another one. Let's see if we can find all the zeros of this function here. Okay, not only all the possible zeros, but all the zeros all together. All right, so what we're going to do is first we're going to make a fraction of the factors of the first thing and the factors of the last thing. There's no number in front here. It's like a 1. So I'm going to use the factors of 6 and the factors of 1. And which one goes on top, the 6 or the 1? The 6. Okay, so what are the factors of negative 6? What numbers go evenly into 6? Well, that would be 1, 2, 3, or 6. And what are the factors of 1? Well, the only factor of 1 is, so the only options for my factors are going to be 1 over 1, 2 over 1, 3 over 1, and 6 over 1. Each of these numbers on top and the 1 on the bottom. So that means that the factors, because it could be positive or minus 1, positive or minus 2, positive or minus 3, or positive or minus 6. Okay, and so now I have listed all the possible zeros. Now, this question, let's not just find all the possible ones. Let's find all the zeros. Let's go ahead and see which of those work as zeros and which of them don't. So let's go ahead and use synthetic division to divide one of these answers out and see whether or not it works as a possible zero. So let's try 1 first, just because it happens to be first on the list. Let's just do a test with synthetic division. Okay, so using synthetic division, I have 1, 2, negative 5, 6. And we go ahead and perform synthetic division here. Bring down the 1, multiply, add, multiply, add. Since I ended up with an 8, that means that 1 is not a 0. So we've ruled out 1. So that one did not work. Let's try it again. Let's try 2 and see if 2 is going to be a 0. Okay, I got 0. So that means that 2 is a factor. 2 is a 0. It does work. So one of our answers is that x can equal 2 plus 3 left. Okay, so let's take this and see if we can factor that down even further. So let's see. Okay, so looking at this and factoring it down, I can see that this is going to factor into x plus 3 and x plus 1. Okay, so setting each of those equal to 0 gives me that x plus 3 equals 0 and x plus 1 equals 0, x equals negative 3, and x equals negative 1. So I have my 3 answers for my zeros. 2, negative 3, and negative 1 are my answers for my zeros. Great.